My name is Azro Azmi bin Junaidi. I from class DKM1D. My number metric is 24 DKM 21F 1007.
Hello, my name is Muhammad Zufi Emir. I'm from DKM1D and my matrix number is 24 DKM 21F 1004. Yeah.
Hello guys, my name is Dev Kumaran son of Puneswaran and I am from class DKM1D. My matrix number is 24 DKM 21F 1161. Hello guys, today my friends and I will be doing a video for the presentation about chapter 7 welding. Let's go.
Gas metal ARC welding GMAW or metal inert gas MIG. This application involves shielding the ARC with argon carbon dioxide and mixture of argon with oxygen and or carbon dioxide. The MIG process does not suffer from this advantage and larger welding current giving greater deposition rates can be achieved. The process is suitable for welding aluminium, magnesium alloys, plain and low alloy steels, stainless and heat resistant steel, copper and bronze, the variation being filler wire type of gas shielding the ARC. Welding principle. During this process, an electric ARC is used to heat the weld zone. The electrode is fed into the weld pool at a controlled rate and the ARC is shielded by a protective gas such as argon, helium or carbon dioxide. Gas metal ARC welding can be either the short circuiting process or the spray ARC process. The short circuiting ARC process operates at low current and voltage. All metal inert gas welding is classified as semi-automatic since the electrode fits into the weld according to a present adjustment. After marking an initial adjustment, the welding operator merely moves the gun along the joint. For effective application, the welding operator needs information concerning power requirement, welding gun, section of shielding gas, type of filler metal, and job procedure. MIG welding technique. There are three methods of igniting the ARC. The gun switch operates the gas and water solenoid, and when released the wire drive is switched on together with the welding current. The gun switch operates the gas and water solenoid and strikes the wire and on the plate. Operate the wire drive and welding current. The gun switch operates the gas and water solenoid and wire feed with welding current, known as scratch start. As a general rule, deep transfer is used for thinner section up to 6.4 mm and for positional welding, whilst spray transfer is used for thicker section. Those MIG techniques are generally listed as below. Number 1, the gun is held at an angle of 80 or slight less to the line of the weld to obtain a good view of the weld pool. Welding proceeds from right to the left with nozzle height 6 to 12 mm from the wood. Number 3. If the nozzle is held too close to the wood, spatter may build up, necessitating frequent cleaning of the nozzle, while acting between nozzle and wood can be caused by a bent wire guide tube allowing the wire to touch the nozzle, or by spatter build up, short circuiting wire and nozzle. Number 4. Check the sufficient fit rolls, pressure or looseness wire due to wear in the rolls 32. Number 5. Root run is performed with no wave and filler runs with a little wave as possible, consistent with good fashion, since excessive waving tend to promote porosity. Number 5. The least projection commensurate with accessibility to the joint being welded should be aimed at. Backing the strips, which are welded permanently onto the reverse side of the plate by the root run, is often used to ensure sound root fusion. Backing bars of copper or ceramic with grooves of the required penetration bit profile can be used and are removed after welding. Cadet shielding gas selection. The primary purpose of the inert gas is to shield the weld crater from contamination. No single inert gas is satisfactory for all welding conditions. Some specific jobs are more efficiently welded with a mixture of gases. Shielding gas may also affect: Number 1. Transfer of metal across the ARC. Number 2. Fusion and penetration. Number 3. Shape of weld deposit. Number 4. Speed of completing the weld. Number 5. Ability of filler metal to flow over the surface without undercutting. Number 6. Cost of the finished weld. Cadet shield filler metal. Electrodes used for filler metal with the MIG process are much smaller in diameter than those used with the metal ARC process. Size may range from 0.4 mm to 5.5 mm in diameter. Small diameter electrodes require high feed rates from 100 to 1400 inches per minute. The composition of the electrode usually matches that of the base metal, but for welding high-strength alloys, the composition of the electrode may vary widely from that of the base metal. The last advantage and disadvantage of GMAW welding compared with normal ARC welding. The advantage is: Number 1. High deposition efficiency when used in a certain transfer modes. All electrode weld is deposited into the weld, whereas with other processes you must account for stub loss, flux or slack. Number 2. No slack to chip as compared to SMAW and FCAW. The process can be used on thin material with relative ease if properly set. Gtaw can also be used on thin material, but in many cases such as auto body GMAW win hands down. Low hydrogen weld deposit with all electrodes. Number 5. High production factor since no slabs is required to be removed and use a continuous electrode. Number 6. With the parameters properly set for the application, anyone can weld after a very short amount of practice. Lastly, one given electrode size can be used on various thickness of material productively as compared to SMAW and Gtaw. After that, the disadvantage is number 1 requires a wire feeder which is difficult to move and can sometimes be a maintenance or repair burden. Number 2, needs shielding gas, so welding in windy condition can be difficult. Number 3, no slack system, so out of position weld are sometimes more difficult. Number 4, increased chance of lack of fusion if parameters and welding technique is not controlled. Number 5, the gun is difficult to get into tight places. Last, number 6 is not suitable for windy condition. Thank you.
Gas tungsten arc welding, Gtaw, also known as tungsten inert gas, TIG. Welding is a process that produces an electric arc maintained between a consumer tungsten electrode and the part to be welded. The heated affected zone, the molten metal, and the tungsten electrode are shielded from atmospheric contamination by a blanket of inert gas fed through the Gtaw torch. Inert gas, usually use argon, is inactive or deficient in active chemical properties. The shielding gas serves to blanket the weld and exclude the active properties in the surrounding air. Inert gas such as argon and helium do not chemically react or combine with other gases. They pose no odor and are transparent, permitting the welder maximum visibility of the arc. The Gtaw process can produce temperature up to 35,000 Fahrenheit or in Celsius 19,426 Celsius. The torch contributes heat only to the workpiece if metal required to make the weld, and it may be added manually in the same manner as it is added in the oxyacetylene welding process, or Insufficient may be added using cold wire feeder. TIG welding machine. Gas tungsten arc welding requires conventional welding machine with the following accessories such as torch, lead cable, and hoses. Inert gas supply and flow meter for measuring amount of shielding gas. Water cooling system for water cooled torch. High frequency spark unit attached to the output leads of the power supply. The finish weld will be greatly affected by the current polarity. For example, aluminium is welded with alternating current plus superimposed high frequency current. Improper electrical connection will cause the electrode to overheat and poor penetration. Current selection must be made with care. When electrode is connected to the negative terminal, electrons pass through the arc, bombard the base plate. You can see the figure 7.41. it is shown direct current rate polarity, and 7.42 direct current reverse polarity. In welding aluminium, this method is used to remove surface oxidation while an electrode positive connection furnish and cleansing effect. It also heat the tungsten electrode. The electrode may get hot enough to melt, transfer to the weld pool, and contaminate the base metal. When this happens, the electrode must be removed and its end broken off, and it must ground to the shade. Alternating current offers the advantage of both direct current straight polarity and direct current reverse polarity. Shielding gas is used with the process. Shielding gas used with this process and atmosphere free from contamination and also provide a path for arc transfer. The path creates an environment that helps stabilize the arc. The gas and the arc activity also perform cleansing action on the base metal. Both argon and helium are generally used for this process, but argon is preferred because it is cheaper and provides smoother arc. Helium, however, helps produce deeper penetration. The table shows the remark of metal and shielding gas.
Next is about filler metal. Filler metals are selected to meet or exceed the tensile strength, ductility, and corrosion resistance of the base metal. The usual practice is to select a filler metal having a composition similar to that of the base metal. For most efficient application, select clean filler metals of proper diameter. The larger the diameter of the filler metal, the more heat is lost from the weld pool. Grinding the tungsten electrode produces dust and flying sparks which can cause injury and start fires. Use local exhaust, force ventilation at the grinder, or wear an approved respirator. Read MSDS for safety information. Consider using cerium or lanthanum-based tungsten instead of thorium. Thorium does contain low-level radioactive material. Properly dispose of grinder dust in an environmentally safe way. Wear proper face, hand, and body protection. Keep flammables away. Method. First, workpiece. Make sure workpiece is clean before welding. Second, work clamp. Place as close to the weld as possible. Third, torch. Number 4, filler rod if applicable. Number 5, gas cap. And last, tungsten electrode. Here is the cut lines. The inside diameter of the gas cap should be at least 3 times the tungsten diameter to provide adequate shielding gas coverage. For example, if tungsten is 1/16 in diameter, gas cap should be a minimum 3/16 in diameter. Tungsten extension is the distance the tungsten that extend out gas cap of torch. The tungsten extension should be no greater than the inside diameter of the gas cap. ARC length is the distance from the tungsten the workpiece. Here I show you some advantages and disadvantages of Gtaw. Advantages is concentrated ARC permits pinpoint control of head input to the workpiece, resulting in a narrow head affected zone. No slack. No requirement for flux with this process. Therefore, no slack to obscure the welder's vision of the molten weld pool. No sparks or spatter. No transfer of metal across the RC. No molten globules of spatter to contend with, and no sparks produced if material being welded is free contaminants. Little smoke or fumes. Compared to other RC welding processes like stick or flux core welding, few fumes are produced. Like small metals and metals alloy than any other RC welding process. Good for welding thin material, and last, good for welding dissimilar metals together. Disadvantages: slower travel speeds than other processes, lower filler metal deposition rates, hand-eye coordination is a required skill, brighter UV rays than other processes. Equipment costs can be higher than with other processes. Concentrations of shielding gas may build up and displace oxygen when welding in confined areas. Ventilate the area and or use local force. Ventilation at the ARC remove welding fumes and gas. If ventilation is poor, wear an approved air supplied respirator.
What is welding defect? Welding defects may be defined as a discontinuity or discontinuities that fail to meet the minimum acceptance per standard or specifications. Defects may occur in excessive conditions outside the acceptance limits, which risk to compromise the stability or the functionality of the welded structure. Furthermore, there are also acceptable discontinuities. The same type of discontinuity of a lesser degree might be considered harmless. There are 9 types of common welding defect and its prevention. Number 1, insufficient penetration. Number 2, improper fusion. Number 3, porosity. Number 4, slack incursion. Number 5, overlap. Number 6, spatter. Number 7, cracks. Number 8, arc strike. Number 9, undercut. Insufficient penetration. Definition: incomplete penetration occurs when the root of the weld bit does not reach the root of the joint to weld the opposite surface in the part. When the weld metal does not extend to the required depth into the joint root. Causes: improper welding technique occurs in materials such as nickel-based alloys, stainless steel, carbon steels, and tin alloys, using high speed of electron beam welding. Prevention of insufficient penetration. Using a proper welding technique reduce the chances of nacreous cracking. Using proper materials for welding. Using a constant speed during the welding process. Improper welding technique. Second is improper fusion. Definition: weld discontinuity in which fusion did not occur between weld metal and fusion faces joining or adjoining weld bits. Incomplete fusion occurs when the welder does not accurately weld the material and the metal solidifies, which leads to a gap which is not filled with the molten metal. Causes. It occurs because of the low heat input. When the weld pool is very large and runs ahead of the arc, then the angle of the joint is too low. Incorrect electrode and torch angle may also lead to incomplete fusion. And finally, improper bead position. Prevention of improper fusion. First, increasing the welding current and decreasing the travel speed helps in removing the chances of incomplete fusion. Reduce the deposition rate, increase the joint angle, and finally, try to position the electrode and torch angle properly so that the edges of the plate metal melt away. Then porosity. What's the definition of porosity? It is a cavity type discontinuity void formed by gas entrapment during solidification. Gases present in well environment H2, N2, O2, CO, CO2, etc. from false covered electrodes. These gases trapped during solidification and cause porosity. Causes. Improper coding on the electrode, longer arcs, faster arc travel speeds, too low and too high arc current, incorrect welding technique. So what's the prevention of porosity? First, use low hydrogen welding process. Filler methods in deoxidizers for excessive H2N2 atmosphere. Use preheat or increased heat input to combat high solidification rate. Clean joint surfaces and adjacent surfaces. Finally, reduce excessive moisture. Use recommended procedure for baking and storing electrodes. Slab incursion. Definition. Incursion happens when slab incursion. Definition. Incursion happens when non-metallic materials such as slag and oxidize become trapped between the base metal and the weld, the different bits of the weld, or in the weld metal itself. Incursions can lead to the weakening of the weld, even to the point of failure. What are the causes of slag incursion? Slag is formed if the welding current density is very small, as it does not provide the required amount of heat for melting the metal surface. If the welding speed is too fast, then also slag may occur. If the edge of the weld surface is not cleaned properly, then also slag may form. Finally, improper welding angle and travel rate of welding rod is one of the causes also. Prevention. Increase the current density. Adjust the welding speed so that the slag and weld pool do not mix with each other. Clean the weld edges and remove the slags of previous weld layers. Finally, have a proper electrode angle and travel rate. Fifth is overlap. What's the definition of overlap? Overlap occurs when the face of the weld extends past the toe of the weld. The filler material is unable to fuse to the base material as it flows over the extent of the weld joint and then cools down. What are the causes of overlap? Amperage, traverse bead, electrode selection and usage, and welding technique as well. What's the prevention of overlap? First of all, use a proper technique for welding. Use small electrode and less welding current. Spatter. Definition. Spatter as metal particles expelled during fusion welding that do not form a part of weld. Small particles of weld metal expelled from the welding operation which adhere to the base metal surface. Causes. High welding current can cause this defect. The longer the arc, the more chances of getting this defect. Incorrect polarity and improper gas shield. So, what's the prevention of spatter? Reduce the arc length and welding current. Number 2, use the right polarity and according to the conditions of the welding. Third, increase the plate angle and use proper gas shielding. Cracks. What's the definition of cracks? Cracks are a common welding defect that occurs during the welding of aluminium. They form at the end of the weld bead. Welding cracks can be present at the surface, inside of the weld material, or at the heat affected zones. If crackers are not taken care of, then they will lead to the creation of stress points that will eventually cause cracking to occur within the weld. Cracks is known as crack tissues. What are the causes of cracks? Poor ductility of the given base metal. The presence of residual stress can cause a crack on the weld metal. The rigidity of the point which makes it difficult to expand or contract the metals. High content on sulfur and carbon, then also the cracks may appear. Using hydrogen as a shielding gas while welding various materials. And now, prevention. Use appropriate materials may decrease the chances of crack. Preheating the weld and reducing the cooling speed joint helps in reducing crack. Reduce the gap between the weld joints by using reasonable weld joints. And finally, the clamping force slowly which increases field to capacity of welding material. Arc strike. What's the definition of arc strike? An arc strike is a discontinuity resulting from an arc consisting of any localized remelted metal, heat affected metal, or change in the surface profile of any metal object. Arc strikes result in localized base metal heating and very rapid cooling. When located outside the intended weld area, they may result on hardening or localized cracking and may serve as potential sites for initiating fracture. Actually, what are the causes of arc strike? There are two. One is improper grounding of the workpiece, and another is failure in bending and cyclic movement. So, what will be the prevention of arc strike? First, place the grounding clamp in the workpiece, and the metal should be clamped onto should not contain any rust paint or other coatings. Finally, undercut. What is undercut? Undercutting is when the weld reduces the cross-sectional thickness of the base metal. Undercut appears as a narrow groove on the base metal adjacent to the weld metal along the edge. Undercut always runs parallel to the weld metal. It acts as a stress razor during fatigue loading. What are the causes of undercut? First, high welding current and arc voltage. Second, large electrode diameter. Third, incorrect electrode angle. finally, longer arc length. So what will be the prevention of undercut? Use the multi-pass welding process. Then regulate the length of the arc. Proper weaving technique. And finally, use appropriate use of shielding gas. As you guys can see, now I'm going to explain about welding distortion. Welding distortion can be defined as the non-uniform expansion and contraction of weld metal and adjacent base metal during the heating and cooling cycle of the welding process. Actually, there are 6 types of welding distortion: longitudinal shrinkage, transverse shrinkage, angular distortion, bowing or longitudinal bending, rotational distortion, buckling distortion. And what's the main causes of welding distortion? A. Non-uniform expansion and contraction. B. Internal stresses. C. Welding process and procedures and material properties. So, what will be the effects of welding distortion? A. Complicate further fabrication. B. Reduce application of the structure. C. High cost of rectifying deformations. You guys can see in my 28, 29, 30, 30th, 31, 32 and 33 slide. For 6 slides, I would have explained about the the types of welding distortion. I hope that everyone would take note and read about the 6 types of welding distortion. As we are going to end our slides, I'm going to explain about how to minimize distortion. Actually, there are 11 types of ways to minimize distortion.
This is transverse shrinkage. Next is angular distortion. And then bowing or longitudinal bending. Rotational distortion. As you guys can see, there are the pictures about the rotational distortion. And finally, buckling distortion. As you guys can see the figure of buckling distortion, and on the right, that's the relationship for buckling distortion of butt weld for different. And now we are going to look into how to minimize distortion.
First is size of weld. Second, intermittent welding. Third, fewer weld passes. Fourth, welding placement. Fifth, balance around the neutral axis. 6. Presetting parts. 7. Alternating welding sequence. 8. Clamping. 9. spinning. Then minimize welding time, and finally strong back.
We are at the last slide of our presentation.
I hope everyone would like this video, and thank you so much for supporting us. My members and I took so much of time to create this slide so that everyone would get benefit from this video and from this slide as well. I hope everyone would appreciate our video, and if you guys can subscribe my channel, it would be much more appreciated. Thank you so much everyone, and bye.